We pull into gas stations all the time, right? It's just this quick, routine stop. But what if I told you that the part you see, that's just the beginning? We're about to dive into this massive, high-tech world that's operating right under your feet. So you're standing there, filling up your car. Have you ever actually thought about what's happening right underneath you? I mean, where does all that fuel even come from? And what kind of complex system is working to get it into your tank safely? That's the big question we're digging into today. Yeah, it really is like an iceberg. The pumps, the little store, that's all just the tiny bit sticking out of the water. The real action, the heart of the whole operation, is completely hidden from view. All right, so let's start with that tip of the iceberg, what we all see. The pumps, the signs, the convenience store. It's all super familiar. But that's not where the interesting stuff is. The real story begins way down below. Okay, now we're going to dive deep. Let's go below the concrete to the world below your feet, the real heart of the station. This is where huge amounts of incredibly volatile fuel are managed by a system that's, well, it's way more sophisticated than you'd ever guess. Believe it or not, just a few feet under that concrete, you've got these absolutely massive containers. They're called underground storage tanks, or USTs for short. And these things, they are the absolute core of the entire facility. They're the giant reservoirs keeping thousands of cars on the road every single day. And when I say massive, I'm not kidding. A big station can have several of these, and some of them can hold as much as 30,000 gallons of fuel. To put that in perspective, a single 30,000-gallon tank holds enough fuel to fill up an average car more than 2,000 times. That's from just one tank. And of course, they come in all sorts of sizes. You can see here they range from, a pretty small 550-gallon tank all the way up to those 30,000-gallon monsters we just talked about. And get this, one of those big ones can weigh over 20,000 pounds. The scale here is it's incredible. Now, this is super important. There's been a huge evolution in safety. See, the old school tanks were just single wall, basically one layer of steel or fiberglass. But today, the standard is a double wall tank. You can think of it like a tank within a tank. And that design is a game changer because it gives you built-in secondary containment, which is crucial for stopping leaks before they ever get into the environment. But hey, it's not just about building a stronger box. A modern gas station is really a whole ecosystem of safety, like a complex nervous system that's always working to prevent a disaster. Right, so a modern UST isn't just some dumb box sitting in the ground. No way. It's a dynamic, fully automated system. It's got this whole network of sensors and valves and alarms. It's constantly monitoring itself and can react to a problem instantly. So that first line of defense is something called secondary containment, which we just touched on with those double-wall tanks. That little space between the two walls is constantly monitored. So if the inner tank springs even the tiniest leak, an alarm goes off long before a single drop of fuel ever touches the soil. Pretty smart, right? Okay, next up is the brain of the whole operation, automatic tank gauging, or ATG. These are basically electronic probes sitting inside the tank, giving a constant real-time picture of everything: fuel levels, temperature, even checking if any water has gotten in. If anything seems off, the system knows about it immediately.
But what about a threat you can't even see? I'm talking about the vapors. Gasoline is constantly evaporating, and it releases all these nasty chemicals. That's where vapor recovery systems come in. They're designed to capture those vapors, both when the big tanker truck is filling up the station and when you're filling up your car, and then they pipe them right back into the underground tank. Nothing gets wasted, and more importantly, it doesn't escape into the air.
Okay, so let's follow the journey of the fuel, step by step, to see how this all works together. First, the tanker truck shows up. An overfill prevention valve automatically stops the fuel flow so there are no spills. Simple. Then, while the fuel's just sitting in storage, the ATG and all the leak detectors are basically on guard duty 24/7. When you grab the nozzle and pull the trigger, a special submersible pump kicks in, pushing fuel through lines that are, you guessed it, also being monitored for leaks. And in a worst-case scenario, like a fire, there are emergency shut-off valves that can kill the flow of fuel instantly. Seriously, every single step is protected. But even with all this incredible tech, there's still a risk, and it's one that's almost designed to be invisible. It's actually a normal part of how a station works, but it's something researchers are starting to look at really, really closely. So every single one of these underground tank systems has vent pipes. They're there to let the tanks breathe, basically. They release pressure when the temperature changes or when new fuel is being delivered. But here's the thing. What they're releasing isn't just air. It's gasoline vapors, filled with harmful chemicals like benzene. It's a totally normal, regulated part of the operation, but it means these chemicals are routinely being released into the atmosphere. And this is where things get a little, well, concerning. A study found that during certain events, like a fuel delivery, the 1-hour safety limit for benzene exposure could be exceeded as far away as 160 meters. To give you an idea, that's more than 500 feet away from the center of the station. That's a pretty long distance.
And get this, that very same study came to a shocking conclusion. They found that the actual emissions they recorded were more than 10 times higher than the official estimates. You know, the estimates that are used to decide how far gas stations need to be from things like schools and houses. It really suggests that the risk might be seriously underestimated.
So, after all that, why does this hidden world even matter? Well, this whole complex system basically acts as a silent guardian. It's constantly doing this delicate balancing act between our need for fuel and the absolute necessity of protecting our health and the environment. So let's just recap the key takeaways here. First, a gas station is way more high-tech than it looks, and most of the important stuff is buried underground. Second, those modern double-walled tanks and all the automated safety systems are absolutely critical for preventing leaks into our soil and water. But third, those invisible vapor emissions are still a real health concern that we're learning more about. And finally, this whole hidden system needs constant maintenance, regulation, and investment to keep all of us safe.
Look, this hidden world is an absolute marvel of engineering. There's no doubt about it. It keeps our cities and our lives moving. But it also leaves us with a really important question to think about. As our understanding of the risks grows, is all of this invisible engineering truly enough to protect our health and our environment from the very fuel it's designed to contain?